Jupiter was hit by a massive proto-planet long ago. This is NASA's theory concerning a Uranus-sized planet that could have hit Jupiter in its younger days. NASA's Juno mission reveals Jupiter's fuzzy core, and that's what led the astronomers to theorize that the gas giant Jupiter was impacted by a massive protoplanet. This is on Astronomy by Corey Haynes. That's amazing news. A massive planet slammed into Jupiter in its infancy could create the fuzzy core that astronomers observe in the gas giant today. This image is by Suda and Akimoto, Mabuchi design by Astrobiology Center in Japan. In 2016, NASA's Juno spacecraft arrived at Jupiter, and the goal was to peer through Jupiter's dense clouds and see what were the planet's inner secrets. Along with this stunning picture Juno sent back, it's also used its instruments to gaze deep into Jupiter's heart. One of the spacecraft's biggest discoveries was concerning the core. The core was less compact than scientists expected. Instead of a sharp transition between a dense core and a more gaseous outer layer, Juno's reading implied a fuzzy boundary, with the core bleeding into the atmosphere, out to nearly half the planet's radius. Can you imagine that? The core bleeding into the atmosphere. Now astronomers led by Shangfu Liu from Sun Yat-sen University in China put forward an explanation for that fuzzy core. They said the young proto-Jupiter was involved in a head-on collision with a large protoplanet about the size of Uranus. Modeling shows that even if the event happened 4.5 billion years ago, when the planets were still forming, the fuzzy core that resulted could persist even today. Liu and colleagues published their findings just recently, August 14, in the journal Nature. Head-on collision. The most common story, Jupiter's formation, is that it collected its heavy elements first, forming a dense core. This is what usually happens to a planet, from what we know. At that point, it was heavy enough to attract lighter hydrogen and helium gases that make up most of its bulk, and it did so. But that scenario would result in a modern Jupiter with a compact, dense core and then being surrounded by lighter gases, which is what planetary scientists thought it had for many years. But it took Juno's extremely precise gravity measurements to learn that Jupiter's core is actually not dense, but just the actual opposite. It's fuzzy, with the outer core bleeding into the gas around it for thousands of miles. And that finding was a shock to astronomers, as you could imagine. When Juno scientists first reported this finding in 2017. So for that fuzzy core to actually occur naturally, scientists had to come up with some kind of an explanation. They say that some 10 to 20 Earth masses of heavy materials would have to have glomed onto Jupiter after the core finished forming, and after half its gas envelope had already developed. But this is physically unlikely. Once Jupiter started gaining an atmosphere, it should have done so quickly, and that very atmosphere should have repelled any heavier dust grains from settling onto the planet. Now, this theory, is it winning skeptics over to it? Scientists began considering how else Jupiter's fuzzy core might have formed, because all this is really theory up to now. They're saying, what are the chances of the fuzzy core forming like this, in this way? And Shangfu Liu presented the idea of a theory of a massive collision in Jupiter's past, that a proto-planet, he said, some 10 to 20 times the size of our Earth, made of dense materials, crashed head-on into Jupiter's core at some point early in Jupiter's development, in Jupiter's history. Andrea Isella, who is the co-author of the paper, said in a statement, "It sounds very unlikely to me like a 1 in a trillion probability, but Shang Fei convinced me by sheer calculation that this was not so improbable. For one thing is becoming more and more clear: the early solar system was a very violent place where planetary collisions were pretty common, and Jupiter's heavy mass acts almost as a guidance system, meaning head-on collisions are actually more likely than glancing blows if an object veers close enough to Jupiter. The gravity of Jupiter would attract it onto it. Liu's modeling also showed that if such a large head-on impact occurred, it would take billions of years for the core to settle back down again in peace and tranquility, well within the current lifetime of the solar system. While there's no way to run the clock backwards to be certain of this type of a major collision having taken place, it's what caused Jupiter's fuzzy core. The theory holds for now until it's proven wrong, and is an intriguing explanation for Jupiter's otherwise very mysterious center, its leaking core into its upper atmosphere. Unbelievable. I'll leave a link below for you for this. We've recently seen Jupiter shining next to the moon. You can, I guess, see it in the next couple of days as well. Very easily to see. It's very bright next to the moon. Now, at the beginning of '73, several spacecraft performed flybys, maneuvers, and brought them within observation range of Jupiter, according to Wikipedia. The Pioneer missions obtained first close-up image of Jupiter's atmosphere and several of its moons, and discovered radiation fields near the planets were much stronger than expected, but both spacecraft managed to survive the environment. Trajectories of the craft were used to refine estimates of the Jovian system. Radio occultations by the planet resulted in better measures of the diameter amount of polar flattening. After 6 years later, Voyager missions improved understanding of Galilean moons, discovered Jupiter's rings. Jupiter has rings, yes. They also confirmed that the Great Red Spot was anticyclonic and it's growing. Comparison of images show that the red spot changed hue since the Pioneer missions, turning from orange to dark brown, and the torus of ionized atoms was discovered along Io, one of the Jupiter moons. Ionized atoms discovered along Io's orbital path, and volcanoes found on the moon's surface, some in the process of erupting. That's the Jupiter moon Io. As spacecraft passed behind the planet, it observed flashes of lightning in the night side atmosphere. So the volcanoes are going off there. Next mission to encounter Jupiter was Ulysses solar probe, performing flyby maneuver, attained polar orbit around the Sun. During this pass, the spacecraft conducted studies on Jupiter's magnetosphere. The New Horizons probe flew by Jupiter for gravity assist en route to Pluto. The probe's cameras measured plasma output from volcanoes on Io again, the Jupiter moon, studied all 4 Galilean moons in detail, as well as making long-distance observations on the other moons, Himalaya and Elara. Imaging of the Jovian system began September 4, 2016. Now, NASA's Juno mission that we're talking about arrived at Jupiter July 4, 2016, and expected to complete 37 orbits over the next 20 months. The mission plan called for Juno to study the planet in detail from polar orbit. August 27, 2016, it completed its first flyby of Jupiter, sent back the first ever images of Jupiter's North Pole. There will be future probes planned. The Jovian system will be the European Space Agency's Jupiter Icy Moon Explorer, JUICE for short, due to launch in 2022, followed by NASA's Europa Clipper mission in 2025. Jupiter has 79 known natural satellites. Of these, 63 are less than 10 kilometers in diameter and have only been discovered since 1975. The 4 largest moons visible from Earth with binoculars in the clear night, known as the Galilean moons, are Io, Europa, Ganymede, and Callisto. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.